Saxon Algebra 2, Lesson 61. Welcome to a new week, students. We are, let's see where we are. We are starting our fourth week back after Christmas. This homework will be due on February 1st, right? So hopefully you're done through the homework that is done today, January 5th. I will look for your mom's signature on this third week when we talk. And we're just cruising through this big long chunk of the school year. We'll get down here and we'll have another review before spring, or another midterm before spring break. We'll have a review and then the test. It'll work, the timing will work just like at Christmas time. Then we'll come back on April 12th. There won't be any homework due, but then we'll start in on these lessons. After spring break is over, we're going to start talking about the AccuPlacer. As far as I understand it, you guys are all in 10th grade this year. So next year you will qualify for Running Start, which I highly recommend that you go to Running Start, not just for math purposes, but just for your education as a whole. I think you're 10th graders. Is that right? I'm pretty sure you are. You can't be 9th graders. No, you have to be 10th graders. There is one more level of Saxon that you can take as an 11th or 12th grader. It's this little gem, Advanced Mathematics, which is, it's more than just algebra. That's why he doesn't call it Algebra 3. It gets into a lot of trig and pre-calculus. It's delicious. It is college level work and it prepares you beautifully for the pre-cal classes at Edmonds. So that's why a lot of students go ahead and take it with me for a third year of algebra, and then take that prepares them to take math at the college as a senior. So when we get down here, we'll talk more about AccuPlacer, Running Start. I don't even know if you plan to go to Running Start. I hope you do. It's a great deal. It's a great experience. My daughters all did it. Most of my students do it. High fives, but I just wanted you to see that here's regular life, and then down here is where we'll start talking about, okay, are you going to do AccuPlacer? What is your life all about? I mean, it won't be quite that cosmic. Okay, but let's talk about something really relevant and down to earth, like chemical mixture problems, okay? It's going to be fun. First, let me remind you of what type A looks like. Type A is the kind where we have two containers of something liquidy, and it's usually the same chemical, but we have a percentage that is too high and we have a percentage strength that's too low. So we add some of both in order to end up with a middle percent that is just right. And we talked about how we pour it and then we dump it, right? Okay, and then we set up two equations. System. And first we just do P plus D, and then we multiply P and D by the percentages, right? Okay. This is kind of like the quantity, and this is like the value statement. That's a very thorough review of our type A's, right? Type B's are slightly different, and the fascinating thing is that the type B will allow you to solve this kind of a problem, but it's broader as well. So the type V, if only I could speak, life would be so much easier. The type B is a more versatile approach. But type A is nice too, so that's why John throws them both in. Let's take a look at type B's on the next page, because I want lots of room. Type B, here we go. Let's jump into the example and I'll explain as we go. How much water must be evaporated from 10 gallons of 100 gallons of a 10% brine solution to get a 40% brine solution? Okay, what? This time we're not talking about pouring these two things together. We're talking about taking a solution that's too strong and evaporating it. So this is a new kind of diagram we're going to use. We're going to have our starting thing, and then we're going to introduce some change to it. It can be plus or minus, but this is going to be where we write about the change, and then that's going to yield us some sort of ending element in, oh, this should say change. And then this will be the form that we want. Okay, so let's start with this one. How much water must be evaporated from 100 gallons of a 10% brine solution? I've got to have the water in there. To get a 40% brine solution. Now, first of all, what the heck is brine? Brine equals salt plus water. We live near salt water, so we are more likely than other students to understand that brine is another name for salt water, the briny deep. Have you ever heard that? And when the percentages are low like this, the salt is usually the lower percent and water is a higher percent. Okay, so if we're talking about 10% brine, that means the salt is 10%. The water would be 90%. We want to evaporate some of it. We'll talk about that in just a minute. And we want to end up with 40% salt, and then that would mean 60% water. Keep that in mind. Push it toward the back. We're going to come back to that idea that there are actually two components here. And we're going to get to more of that. Now, the change that we're introducing in this particular problem is we're going to evaporate. Okay? And when we evaporate, I'm going to tell you something and I don't want to confuse you. When we evaporate, what happens? Water goes away, right? Water molecules change from their liquid state to their gaseous state and float off into the atmosphere. So what happens when we evaporate, this is, we're introducing some kind of change. What happens when we evaporate, we lose water, right? Well, if I'm talking about water in this evaporation, this change area, then I want to be talking about the water in these two. I don't want to be talking about the salt percents. I want to be talking about the water percents. So I'm going to change my percentages from the salt to the water. So if it's 10% salt, that means it is 90% water. And if I want 40% salt, that means I want 60% water. And now when I evaporate, I'm going to evaporate some amount that I'm going to call E. That's the amount that I'm going to evaporate. It's going to be a subtraction, right? Because when you evaporate, the water goes away. My fingers are doing this to show it going up into the air. And it will be 100% water, right? No salt is going to evaporate. So now what I'm doing is I'm looking only at changes to water all the way across. 90% minus some amount that evaporates will give us 60% water in the end. Does that make sense? So what we can do is say that the amount that we have, we've talked about the percentages. Now let's look at the amount. We have 100 gallons. We're going to subtract E, and so this is going to equal 100 minus E. All right? So now we're ready to write our two statements. The first statement is about the quality. 100 minus E equals 100 minus E. That seems so basic, it's not even helpful, right? But here's another difference between these two problems. We don't really have to build a system of equations because we only have one variable. We just use this as sort of a starting point. Now what we're going to do is apply the percentages, right? So 100 at 90%, I'm going to write it as 0.90. Right, there's my 90%, 100 gallons, minus E at 100%. This one represents the 100%, equals 60% of 100 minus E. Quantity and value, but we don't need to solve both of them. We just use the quantity statement to build the value statement. So they build on each other. We don't have to use a system to solve because there's only one variable in all of that. Oh, interesting, right? Okay, so how the heck are we going to solve this? Well, you have a really good experience at this. The first thing we're going to do is we're going to get rid of this decimal because I don't like it. We're going to jump everybody one jump. Okay, that's better. Now let's multiply. 9 times 100 is 900. Minus, this became a 10. E equals, now this is a 6, so it's 600 minus 6E. All right, I feel good about that. Let's do this. Let's add 10E to both sides. We'll swim the E's to the right, and then we'll subtract the 600. So the numbers flow to the left. Goodbye, goodbye. 300 equals 4E. Divide by 4. Gracie's sitting on the couch right next to me, chewing on a giant rawhide bone with her chin on my other math books. Huh. I'm glad she's comfortable. Okay, so what we get is E equals 75. That represents this, which is 75 gallons need to evaporate in order to get this from 90% water to 60% water. So what we had to do, the confusing part of this problem, is we set up this change that was going to happen, starting, in this case, we subtracted. Later we'll do one where we add. And in our change, we introduced this change, and we subtracted some water, and then we had our ending unit, and we had to decide how to express the strength of these starting and ending units. And the trick is to express them in the same chemical, if you will, the same material as the change is taking place, okay? So we want to use the same element, let's just say, water or salt. Okay, so we think of how our change is happening, and then we make sure that we express those in the same element. Let's do another one, and you'll see. We're going to do a total of 3 of these. And, you know, honestly, they each take up like the whole flipping page, so good luck with that. Oh, hang on. I'm having slight technical difficulties. My battery is not charging. Oh, that's why. The plug came out. I'm going to pause the video, you guys. Oh, wait, I know what the problem is. I think that should be working. We'll see. If it dies, then I'll just have to do a part 2. Okay, next problem. Example 61.2. When Frank and Mark finished milking, they found that they had 900 pounds of milk that was 2% butterfat. Okay. Now, if you're not a dairy farmer, then you don't know that milk from a cow is made up of 2 parts. What we call skim milk, or 0% fat, plus the butter fat. And what we do is, you know how there's like 1%, 2% milk? That tells how much fat has been added to the skim, okay? So, and this is 100% fat. So the farmers separate the two, and then they add butter fat to the milk in whatever proportion they like to create whatever product it is. Like if it's whipping cream or, you know, there's half and half, that's literally half skim milk, half butterfat. So they have their original amount, and then what they're going to do is it says how much butterfat did they have to add to increase the butterfat content to 8%. Okay, so this is our change. That's always the interesting part, and we do that first. And what we're going to do is we're going to add butterfat. And that will be 100% butterfat. And we're adding, so I circled the plus sign. All right? Last time we subtracted, this time we're adding. So now I know I want to express everything in terms of the fat, not the milk. And it said they had 900 pounds of milk that was 2% butterfat. Okay, so I want to talk about this as being 2% because that's the butterfat percentage. And then our ending element, after we add some more butterfat, we want to bump it up to what? 8%. Yes. If they were going to change this by dumping in some skim milk, then I would want to write the percentages for the milk. But instead, we're talking, the change is going to be made using butterfat, so I want to use the butterfat percents for everything. So that's how you go about deciding on which unit is look at the change, figure out what element, ingredient, however you want to think of it. Butterfat is what we're dealing with here, so I want all my percentages to match that. That's the hardest part of these, you guys. So the amount that I add, I'm just going to call it B. And then this will equal 900 plus B, right? So there's my first statement. 900 plus B equals 900 plus B. Sometimes it's helpful to put parentheses around that one so that when we go to apply the percentages, it works. And now that's what we do. We apply the percentages. 2% is 0.02 times 900 plus the butterfat is 100% butterfat, so I can write 1.00 B equals 0.08 900 plus B. Okay? This part is familiar. We're just identifying. And again, because we only have one variable, we don't need a system of equations. System of equations are necessary when we have two variables. All right, now we're ready to just solve this. Let's bump the decimals twice. We have 2 times 900 plus 100B equals, let's see, that'll be 72,000. I should have just multiplied that one. Plus 8B. This I can see is 1,800. All right, let's swim the plain numbers this way. And swim the B's this way. Goodbye, goodbye. 92B equals, let's see, what would that be? 5,400. And let me just check and make sure I'm on track. Yes. And that comes out to that the amount of butterfat that we need to add. I'm just going to copy John's number. I'm not going to do the division. You can do that with a calculator today. I should show you, sitting right here on my bookcase next door to me is my husband's circa 1970 Texas Instruments calculator. Isn't this a gem? There's the little Texas Instrument logo. I don't know if you can see it. But look, this is what an early calculator looked like. Isn't it just quaint beyond words? Look how chunky. A little bit of staining there. There's, what was this? I don't know what this is. Made by Texas Instruments. It's a gem. So it just sits here for decorative purposes only. Oh, look. This is my husband. He had a label maker when he was in high school, and he put his name on everything. It's great. He was very sincere about his property rights. Okay, so what this comes out to, if you solve it, is 58.7. And that is how many pounds of butterfat we would need to add in order to bump that from 2% fat to 8% fat. 900 pounds. Okay, one more. You know what I'm going to do? I'm going to end this video, check to make sure it's charging properly, and then come back in a little extra piece for you because I'm really paranoid that it's going to die in the middle of the problem, and I don't like when that happens. I want to be proactive. Okay, so pause, and we'll come back and do the last example in the next video. Thank you, bye.